You're going to kick us off, Parker, or shall I get started?
Yeah, happy to kick us off. Welcome everybody to the last of our December Power Hour sessions. If you've joined for multiple sessions this week, thank you so much. We've loved having you. If you've not, we do have some recordings that you'll be able to find on our website here shortly. On Wednesday, or Tuesday rather, we talked about event management. On Wednesday, we talked about monitoring and metrics. And today, as you can see, my colleagues are going to discuss health log analytics. I would also be remiss if I didn't note that this is just the first of what we hope will be many series in the Power Hour, many sessions of the Power Hour series. We're excited to plan for 2025. As we're looking forward, we're also very eager to hear from you in terms of what you'd like us to discuss in these sessions. We hope to find a right balance of kind of technical content and interesting use cases, novel demos, that sort of thing. So if there's anything that comes to mind when you hear those terms, please feel free to let us know. There will be a survey at the end that you can access. You'll see a safe harbor notice here in just a moment. So I will also say that anything that we discuss here that is forward-looking is subject to change. There will be a roadmap session at the end where we discuss some of the things that are coming up with regards to health log analytics. So know that while we do always try to ship what we say we're going to ship on time, things in the future are always subject to change. And with that, I will pass over to my colleagues to introduce themselves and talk a little bit about what we're going to be going through today.
Thank you for that, Parker. Your presenters today will be myself. I'm Remco Lingers. I'm based out of the Netherlands. I will introduce my other colleagues. We won't go around the horn. So we have Dennis Kuipers. He's currently situated in Switzerland. He'll be doing the demo. Mauro will be explaining us about health log analytics, all the technical details. I will be doing the intro from where health log analytics sits in our AIOps offering. And Parker will later take us home with forward-looking statements on a roadmap where what's going to be coming in the short term for health log analytics. So Parker already noticed safe harbor statement at the end. There may be forward-looking statements, so we'll put this in our slides whenever we do that. This is the third of this week's series. Recordings of the previous ones will be available in the communities at some point. Yep, this is the third and final one. We think we'll be using most of the 90 minutes that we have. We're doing the introduction now. We'll see what log analytics' role is in our AIOps offering. I'll do that, and then Mauro will take concept and technical overview. Dennis will take us through a live demo and show us what can be done, and we'll close 10 minutes roadmap. Feel free to ask questions in the Zoom Q&A. My colleagues and myself, we will be answering that as we go along, so feel free to use that. If any of the questions is maybe interesting to answer in public, we may do that. So we've used this adopted Gartner wheel for the last couple of days, and we changed that a little bit to our liking. So where's the role of log analytics in this model? So first of all, it is the automation of the detection part of anomalies in log files, as the logs are streamed in real time to the ServiceNow platform. So it's a very, very important step in the operations part. And then the second part is using machine learning to detect anomalies in those logs and surface those logs to the operations people. And this can work in a fully unsupervised manner. On top of that, of course, we have now our Now Assist that will put an additional Gen AI solution on top of the foundational data that comes out of all of this. And that can make reasoning in the logs, potential root causes, and describe the problems. I would say log analytics is the major part of ServiceNow's AIOps proposition. So if you're in part of any kind of post-mortem or ITIL problem solution, then you'll inevitably look at we had a P1 outage. What could we have done maybe to prevent it or to catch this earlier? And 9 out of 10 times, or maybe 8 out of 10 times, you'll end up in the logs and find that logs, yes, there were early warning signals in those logs. So in this detect to correct value stream, you will see where our log analytics plays a role in preventing, first of all, finding problems and maybe possibly preventing a P1 from ever occurring. So health log analytics is we collect logs at sources or potentially in a centralized aggregation point. We ingest those logs in the ServiceNow environment, and we detect what normal patterns in the logs are. And when we find anomalies, we can correlate those and attach those to CIs or applications and surface them as alerts or incidents. When you have logs that sit really close to where the problem initially started, that could potentially really help you in identifying the root causes. So it also helps quite a bit in getting really close to the root cause. And health log analytics, I would say, is for your services or applications where they're very sensitive to downtime. So there is a big impact in your business when those applications go down. And health log analytics can be an extremely valuable proposition to minimize the downtime in those critical applications or services. So this is, if you have presentations from ServiceNow before, you probably know this model a little bit. And I'll highlight where health log analytics resides. It is when you basically move from responsive to intelligent, right? You're adding an AI layer on your data and help you and they're highlighted in light green in proactive alerting and preventing common problems from happening because you catch them at potentially the earliest data signals. And Dennis will highlight how early and even before event management systems can see them or monitoring systems can see them. Usually in the logs, you can find minutes, maybe hours before you find the earliest log anomalies. So this helps you to become better self-healing, being more predictive, and get really close to machines being able to self-heal based on early telemetry coming from the applications or infrastructures themselves. So, as I've already discussed, what is a log really? It is a programmer that had decided in his code somewhere, maybe in firmware, maybe in application software, if this situation happens, I really want to leave a mark and I'm going to output some kind of string into a file, and maybe somebody who stumbles upon it can do something with it. So it's either something of note or it's an exception that happens in the software where the programmer thought, this log really needs to be seen. This can be important if somebody wants to troubleshoot this. So this may not have been the log that you were thinking of, but I assure you this is not a mistake because I think I have an interesting metaphor here. Because logs, it can be quite a bit. It's a lot of data. It's streaming. It can be megabytes, terabytes, and some companies even petabytes per day or per week. And humans aren't really equipped to deal with logs. We just don't have the strength or the will or the mental bandwidth or the physical strength to deal with. So what do we do when we have to deal with logs? We use machines to do the heavy lifting for us. And I think that's the metaphor here. We have this really valuable source of data, the logs, but we humans, we can't deal with it very well. So we need machines, aka computers, or a SaaS platform at ServiceNow to deal with that. So because it's quite often very difficult to deal with the large amounts of logs, people tend to ignore them, but they can be really important in troubleshooting and finding problems really fast. So in comes log analytics that deals with computer logs, of course. We know that's what we all mean. But still, humans still can't deal with it. And in comes health log analytics, part of our AIOps offering. So in the previous days, we have seen how to deal with alerts, and alerts can come from metrics and from logs. And if you go back in time, logs generally tend to be the earliest opportunity, the earliest data signals, telemetry, where you can find a problem brewing. So it moves you, if you think like this, as far back in time as you can to the earliest signals. So you really want to have a machine or a software solution that helps you find those initial stages of a problem. That may or may not turn out to be a problem, but at least it gives you a chance before something becomes an incident and maybe a business outage. So that is the AIOps helps you move, log analytics helps you move to the left back in time, catch those early signals. And here is where this log analytics sits in our AIOps, predictive AIOps story, right? We collect event metrics and logs. Logs is what we talk about today. Add individual sources or aggregated sources. We stream those in real time in the ServiceNow platform, and the machine learning does detection, anomaly detection based on that streaming data. It converts it into events that then can be dealt with, can be correlated into alerts and group alerts, and then can be serviced to operators to deal with. So this is basically where health log analytics sits in our AIOps story. So I'm going to be handing over to Mauro.
Yes, Renko, let me share my screen. Okay, good morning. So I will guide through the details of how health log analytics works, so the concept and technical overview of the products. So let's start with this. So look at this slide. The most important part of this slide is the title. So health log analytics help you to find what is the unknown unknowns. What does it mean? Most of the time, the application problems, so the problems, the error that are causing the application downtime are related to conditions that you don't know in advance. So you don't know how to look for most of the time. So HLA, what it's doing, it's look for things work for conditions that you are not aware of in advance. And so how it does it? It does it analyzing in a proactive way using machine learning, real-time logs, and detecting anomalies from the content of the logs before they impact the business that you are supporting, that make your business work. So find the unknown unknowns. This is the important part. So, and how it does it? So imagine that you have logs streaming in the platform. So you can have millions of log lines streaming in the platform. So health log analytics understands inside the logs what is normal. So what is the normal condition? What is the normal behavior? What is negative inside the log that is analyzing, and understand what is anomalous, what is the anomalous behavior. Once you know what is normal, health log analytics can tell you what is anomalous, and so can raise predictive alerts. This is the magic of health log analytics in a completely unattended way. So you don't have to set thresholds. You don't have to have humans to teach the system how to look for and to set thresholds. You can have a completely unattended analysis of your logs, and the system can proactively catch predictive alerts and anomalies from the content of the logs. This is the magic and the fundamentals of health log analytics. And talking about the type of anomalies that health log analytics can signal you inside the console, you have three categories of anomalies. Health log analytics can tell you what is above or below the normal behavior. So you have a pattern. Health log analytics understand what is normal in this pattern and can tell you in a really proactive way when you have a value that is above or below what is normal for health log analytics. So you can tell you if there is a deviation from the normal. This is the first type of pattern that health log analytics can tell you. The second one is something that never appeared before inside the log, and you have an occurrence of this. So the first time health log analytics catch a meaningful pattern. So the first time you have an anomaly. Imagine you have an error inside the log. So the first time you are notified. And then you have the anti-pattern. The anti-pattern, again, is really, really important. Imagine that you have constantly in the log. The normal situation is to have constantly in the log a certain type of message. Suddenly, this disappears. Again, this is something that is abnormal and maybe worth to be taken in consideration and to anticipate a real problem that could impact your application, and so to avoid to have a P1. So those are the three kinds of anomalies that will be you will be allowed to see in the console thanks to health log analytics. But going deeper in the blocks that that allow to the machine to work, what are the building blocks of health log analytics? So we have the first step is being able to collect data, collect logs from multiple sources or from aggregator. So the first phase is the collection and mapping, and we will see what does it mean. Then the raw logs collected will go through another step that is meant to normalize the logs and to eventually, if it's necessary, to parse better the logs to allow the machine learning mechanism and algorithms to work better with the raw logs that we are ingesting. And so the two white boxes are the really important piece where you can manipulate logs that are coming into the platform. The green one is the machine learning that we apply to the logs that can catch anomalies and will help to correlate the anomalies with the other alerts and to go through the diagnosis once the anomaly alerts will be inside the platform, the ServiceNow platform. So we will go through the three big steps and we'll go to the details. Let's start with the data collection and mapping. So the scope of this is to collect logs and to push logs, to stream logs inside the platform. So in this phase, what we do normally is to configure the data inputs. So what are the sources that we interact with to collect logs? This is the really basic, the first steps. Once we do that, we could go to a mapping, and so we can go through something that we call a pre-processor phase. So imagine that you have logs streaming in the platform. The logs could contain sensitive data, information about the users. Imagine the login ID. There could be the IP address. So all the data that you don't want to leave your network can be masked in this phase. So you can pre-process logs and remove the data, the sensible data, the sensitive information that you don't want to leave your enterprise. This is done in mid servers sitting in your environment. So before leaving your premises, before going to the platform. And then in this phase, you can also, for example, imagine that you don't have a really mature CMDB. So you don't have in the platform good enough data about the CIs and the services. Again, in this phase of data collection and mapping, you can again manipulate a little bit the logs assigning the right CI or the right services or the right service for each log you are streaming into the platform. So it's a way to assign and to map a single log to a single CI or a single service inside the ServiceNow platform. And this is, again, a really important part, mainly if you don't have a really mature CMDB. So this is another example. Magnus 2 days ago with the tag-based service, the tag-based clustering gave you an example of how to get value from event management before, even though you don't have a really good CMDB. This is another. You can use health log analytics even though you don't have a really good and mature CMDB, because in this phase of mapping, you can overcome this problem. So again, we want to collect data. How we can collect data? I'm again linking back to the Magnus session 2 days ago. Magnus showed you how inside the service operation workspace, we released the integration launchpad. And from the integration launchpad, you can configure your event ingestion from out of the box data sources, or even using the webhook from completely custom event source. You can do the same. So configure your log source directly from the integration launchpad. So this is a representation of the different sources from who we can get from where we can get the logs. So could be Kafka, could be our agent, could be FileBit, could be any RSys logs through API, REST API, Splunk, TCP/IP. So this is the central pane to configure your data ingestion. And once you click one of the icons, obviously you are redirected with a specific, let's say, configuration pane for Splunk, for RSys, log, etc. So you will be guided in defining what is the mid server that will ingest the log, what is the port that you will use in the mid server for the transport, what is the protocol that you are using, and if you need to put configuration files, in this case on Splunk, to configure Splunk to send our to us logs, the configuration pane will guide through to the definition and building of the configuration files that you will need to put on the source of logs in order to the system to talk with the mid server and ServiceNow and to start streaming log. So it's really simple. You have guided setup for each kind of streaming source you want to set up. Yesterday and the day before, Magnus and the others spoke about the ability of monitor systems or receive events from system, gather metrics from system using the agent client collector. Agent client collector, it's meant also to collect logs from the endpoint, Linux, Windows. So in case you don't want, to configure, you don't have a log shipper already available, you can install our agent, and you can configure our agent to send log to our platform. And we already using the agent, you have already built policies. The agent works with the concept of policies. So there are policies already in place to ship logs from application installed on the OS or from the OS itself. So you just need to activate the right policy, to configure the right policy, to, at the end, to tell the agent what is the path of the log that needs to be streamed to the mid server, and then from the mid server to the platform. So using the agent client collector, all the configuration burden is shifted from the log shipper to the ServiceNow platform, because you configured 99% of what is needed to start streaming log directly from the agent. And it's not a different agent. We have just one agent that is meant for discovery, is meant for monitoring, is meant for streaming metrics, is meant for streaming logs. So it's only depend on the feature that you enable, enabling the right policy. This is what we released really recently, I think last quarter. So the ability we added, this is for the customer that already have health log analytics. So for that customer, we released a new data stream that allow the customer to ingest data directly from the glide sys log. So imagine using health log analytics, you can analyze the ServiceNow logs and the mid-server logs. So you can catch anomalies from the log of the platform itself. And so in this case, you don't have to install any agent. You don't have to, because you are analyzing the ServiceNow glide sys log itself. And so it's really a powerful way to analyze the condition that you are having inside the ServiceNow platform, and to have really early anomalies from the ServiceNow itself. So it's something that each and every customer that acquire health log analytics can use really with 3 clicks of the mouse. And enabling the new, it's enough to have a user with the right role, and you can enable this new way to stream logs related to the platform itself. So this is about the data collection and mapping. So ideally, we connected to a source. We collected to the source and started to streaming log to the platform. What we can do is a phase of parsing and normalization. Imagine that we can stream logs of different types. The logs, as Renko said, are written. So a programmer decided the format of the log, when to write a log, and what is the format of the log that will be written on the file system. So we have this phase of parsing and normalization where we can better structure the log. We can better identify inside the line of log what is the human readable message. If inside the log there's a log line, there is, for example, a timestamp. If there is a part that it's meaningful to identify the severity of the log lines, and if there are in general keys that can be helpful for the anomaly detection and for the root cause analysis of the log so to make the machine learning better. This is the scope of this part, that is the parsing and normalization. So imagine that this is an example of log. So in this log, you will have a timestamp, a part that is the severity, but here you have the really important part of the message. So it is the most interesting part, the real message. And this real message contains a lot of valuable information. So imagine here, you have inside this part, that is the real important part, you have the real message, but you can have a lot of key pair value. For example, the client that is calling a function. You can have the server that is calling that is executing a function. You could have which kind of request you are having, a get, a post. You could have the error inside the log, etc. So what you can do, you can and we will see how you can extract that part that can be valuable, not just to catch anomalies, but to make better the machine learning of health log analytics. And imagine linking back to the example of the log that we saw, there are parts, for example, that could be an error code. So if I'm able to extract from the log using a mechanism that I will show you the error code, we can, for example, to tag this part as a meter. What does it mean? That health log analytics automatically will count how many times the error will happen, and we can see if we have a deviation from what is normal, for example, or if we have a number as the duration of transaction, we can mark it as a gauge. And what does it mean for health log analytics? That if a part of the log is a gauge, we can see what is the normal behavior again of this number, and see if the transaction will go, the time of transaction will go up or down compared to the normal behavior. Or we can have a part from, for example, the request, the GET request. Maybe this is not meaningful for the machine learning, for catching anomalies, for catching anomalous behavior, but could be helpful for the automatic root cause. So I can teach the system, this is a part to be taken in account for the root cause analysis. And how I do it? I do it inside the platform in something that is called the source type structure. So the meaning of the source type structure is to start from a typical line that you can find in a log, and starting from this part, try to understand what are the different keys and what are the different values. And once you do that, you can classify this. For example, you can say, you can attach labels. You can say, this part that I highlighted, it's the real message to be analyzed to get anomalies from the machine learning. This part is the timestamp. This part is the severity. Treat this as the IP address, for example, as an automatic root cause. And if you look at the extraction time, this analysis is made part automatically. So the machine learning analyze the log lines, and it does a first key pair split of the log. So it's made partially from the machine learning, but you can refine this catch using obviously a JavaScript code. So this is, let me say, something that starts completely automatically using machine learning, but can be refined by you using scripting. And I think Dennis will show you how powerful is this part, the source type structure. We are going to the last part of the last step. So after the data collection and mapping, the data parsing and normalization, there is this green box that is the machine learning and anomaly detection. And the idea is, again, out of the log, automatically catch from identify patterns that could be interesting. And so automatically, and again, without any need to teach the system how to look for, because in the last step, in the source type structure, we are just saying, I want to format better the log. I was not saying, look for this or look for that. So the real key point is here. In a completely unattended way, the system will catch for you interesting patterns. So for example, in this example, you have the login failed. So the login failed, if it happens once an hour, it's not something that I need to worry about. But imagine that this will be more frequent, 10 times an hour, 100 times an hour. Maybe this is something that I need to take care of. And the system automatically will signal you that this pattern is above or below the normal behavior. So the idea is to catch conditions you are not aware of. So, and this is the magic of health log analytics. And once, what the machine learning does, first of all, identify patterns. And once the patterns are identified, there is a metrification of the patterns. So once I know that this is a meaningful pattern, I can start counting the occurrence of the patterns. I can define a baseline, and I can see the anomaly detection. So this is the step: patterns, metrification, baseline, and anomaly detection. This is how the health log analytics works. And again, going to this, the last part is, once I have an anomaly, once I have an anomaly means an alert. And so when I have an alert, the alert that is catched from the logs, that is surfacing from the logs, is exactly, from the operator point of view, exactly the same log as the ones coming from events that you saw with Magnus, the same as the anomaly alert that you saw coming from metrics yesterday, and is the same as the alerts coming from anomaly coming from logs. So all these kind of IT alerts, anomaly events, log alerts will enter in the pipeline of work, in the workflow inside your first line of support, second line of support. Will land on the service operation workspace, will be grouped together with other signal coming from events and metrics, and so on. So all the story that you saw yesterday and the day before will apply the same if applied to signals that are really early signals that are coming from logs. A little bit about the architecture. So I already told that you can have endpoints, you can have log repositories. The idea is to send logs to a specific mid server, or a mid server that is one or more mid server that is configured to receive that kind of logs. This is what is inside your premise. Then the logs are shipped to our platform. So if you look at the box ServiceNow, you see the ServiceNow instance. This is the normal glide, the glide system, but you can see also different parts. So you can see Occultus, Magic Base, and an Elasticsearch. This means that when you, as a customer, install on the ServiceNow instance health log analytics, automatically different piece of hardware will be installed inside the data center and connected to your ServiceNow instance. So, for example, all the metrics are will be not in the Glide database, but there will be a dedicated database to host the metrics. All the machine learning will not be done on the Glide, on the ServiceNow instance, but again in a AI engine that we call Occultus, that is meant to that is particular for health log analytics, and all the logs will be stored in an Elastic database that is meant to the search that we will see during the demo and the presentation. So this for saying that starting streaming logs will not affect the performance of your instance, because for do the magic associated to health log analytics, we do use the additional piece of hardware meant to analyze logs, to store metrics without impacting in any manner the performance of your instance. This is the traditional architecture. We are evolving this architecture in an architecture that we call Health Log Analytics 2.0. And in this new architecture, we are again, using the MIT server, but we are using an ITOM gateway, so a cloud service that can be dedicated to the customer. We are using Kafka to better stream logs and to process logs using a parallel processing. And this kind of architecture is available and dedicated to customers that have really heavy quantity of logs that are streamed to the ServiceNow platform. So it's an evolution that we are making to the health log analytics architecture to be always at the pace of at the speed of the logs that are sent, to manage a really huge amount of logs that are sent to the platform, and to be really because the real scope is to stream in a real time logs, to be able to analyze in a real time the logs, and to have really early anomalies out of logs. And so the resilience and the scalability of the platform is really key. So after this long speech, and before handing over to Dennis, a few slides about so once the logs are in the platform, what can an operator do with this massive amount of logs? First of all, the operator, so we are talking about first line or second line operators. So we'll be able, with something that is called log viewer inside the service operation workspace, to query logs. So imagine the power for a first level operator or second level operator to be able to see the log and search inside the log without the need to have SSA access to the local machine. So without bothering the security guys, without the need to have password to access, and so to be at scale, able to browse any kind of logs we are streaming inside the platform. So imagine how powerful is this for the troubleshooting. So I can see the logs, I can build query out of the logs. And imagine that if I want, this what I'm showing you, again, it's not proactive, it's reactive, but imagine that I can browse inside the log. I can find for a condition, particular condition inside a log, and I can generate an alert out of this condition. So it's possible using the log viewer to define a reactive alert that will land inside the express list, inside the service operation workspace, when a condition is met, in a certain time window, when a condition is met for 10 times in this time window. So it's a reactive alert, but it's an alert that streaming logs you can get out of logs. This is, again, not proactive, but reactive. And then this is the idea of being proactive, to be able to have in the service operation workspace some alerts that are based on anomalous behavior that the machine learning is able to catch inside the log itself. And so to be able to say, look, I have the volume of logs of a certain database, it's above the normal. What's happening? So without teaching the system to look for this particular metrics, it's totally catched in a not supervised way, and you will see during the demo the power of this. And as Renko already mentioned, on top of the ability to ingest logs, to catch automatically anomalous behavior from the logs, and to signal this anomalous behavior in a really predictive way in order to anticipate problem, you can put on top of this generative AI. And this is really important talking about logs. The messages coming from logs could be really sometimes cryptic. And I will show you an example in the next slide. So being able to apply generative AI. So the ability to summarize in a really powerful way, a simple way, what is the summary of the issue, what is the analysis, what is the meaning of the log line that you are seeing. It's really, really powerful and can be really an accelerator for first line support people to understand. So to get a really early signal that something is broken, and to have an assistant, the Now Assist, that it's able to summarize what is happening and to give a really simple description on what's happening. And this is not my last slide, but we are going to the end. And this is an example of an alert. Remember the new connector to analyze logs from the ServiceNow syslog. So this is an example. This is an example of an anomalous behavior taken from, so it's a Java exception taken from the syslog of ServiceNow, and the description could be really, really cryptic and not so easy for a first line operator. But using the generative AI, look on the right, there is really a simple explanation of what is happening out of this really cryptic message. So the scope of health log analytics is say, look, operator, there is something that is anomalous inside the log, and this is the alert. The scope of the generative AI is to summarize and make it really understandable. And this is really a value of, I can get something that is going to be, that potentially will break my service really early, and I have a tool that allow what is in duty in that moment to understand really, really quickly what is happening with inside the system. Last slide for me. So, and why is important health log analytics? What is the business value of having health log analytics? So, health log analytics, the bottom, the real value is to avoid P1. And we know that a P1 is costing money. It's costing money, so hard dollars, but also soft dollars, reputations, loss of customers. So a P1, it's something that I need to avoid. And having a system that give me in a really unattended way signals that something in one application is deviating from the normal behavior can save my life, can reduce drastically the P1. So it's health log analytics it's like an assurance. So if you don't use, you are paid for something that you are using. But if you have an accident, it saves really your life because it's helping a lot. So the health log analytics is to reduce the P1, to help you understand that a P1 it could happen in 1 hour, 2 hours, and so avoid this. So health log analytics is not for your infrastructure, but for your crown jewels, for the application that really matter, that make you able to deliver your services, and to be sure that you will avoid the P1. So this is the really business value and the value that health log analytics can give you. So this is my last slide, and I hand over to Dennis for the demo.
Thank you, Marlo. So I'm going to share my screen.
I stop share. Okay.
Okay, so before I really start drilling down into the alerts that have been generated out of the log analytics, I want to give you some context about the environment that I'm using today. So what we see here is my ServiceNow instance, and my ServiceNow instance is connected to an real-time environment with a real-time application that has been active by some load generators. And there's a lot of some activities done from a deployment point of view and other things that's happening when an application is active. So what we see here is the noise reduction from the alerts that, or let's say the events that the application is sending to my ServiceNow instance. So what we see here is the 98% of alert compression, meaning that events will be compressed into alerts. And the second defense is basically the grouping of my alerts into single actionable alerts, which is 61%. So both together, it will end up in a 97% incident compression rate, which of course is what we want because that makes us much more efficient. So what we see here in the graph below, we can see the top alert sources. As you can see, most of my alerts is coming from OpenTelemetry, which I will explain later. And then we can see the log analytics is a second source of alert generator. What we see as well is the group alerts. So basically what you see from those two bars is that we do also the group alerts, or let's say the noise reductions into the group alerts. So that's basically what we have explained over the 3 last days. The noise reductions, translating into incidents. So everything what Magnus and Dominique has explained in the previous sessions. Just to give you some overview of the logs that I'm streaming in. So my logs are coming from different sources, which are the microservices that are part of my boutique service. We can see kind of a breakdown into the different application services, into the different hosts. So in the last day, I have streaming in 2.5 million log lines. There have been 46 alerts being generated out of it. And then we can see basically in background of the debug statements, the warnings, the info, and the errors. So as you can see, it's really in a live environment with live logs that are streaming into my ServiceNow instance. Just to give you some context of the application itself. So as I mentioned, I'm using the boutique application, which consists of different microservices. And here we can see basically the breakdown of this boutique service into the different microservices. What we see here below is the infrastructure, the Kubernetes cluster. So this will give me the total view, not only from an application context point of view, but also from an infrastructure point of view. And you can see with the red circles, those where the alerts are coming in and being assigned to the microservice. Okay, so a bit more of the context of the situation that I can explain. What we see here is definitely some latency issues, as you can see here, which is happening this afternoon or early afternoon. And we can see that the first kind of reports about latency issues started at 11:52. We can see here the rate, the transaction rate, and we can see that the rate is going down a little bit around 11:46. And what we see as well here is that there was a deployment done at 11:32. And we can see here for the card service that also here the rate is going down and the latency going up. And of course, that's not surprising because if you go back to the service map, we can see that the card service feed into the front end, which of course explain why we see this kind of behavior here. Okay, so we can see that at 11:42 of 48, we can see that the rate is going down, and around 11:52, the first kind of traces are started reporting very high latencies. Okay, so how does it translate that into the alerts that we send over to ServiceNow, and how does translate that into the log analysis. So to show you that is that I going to show you the express list. And the express list shows me two types of main group alerts. The first one tells me something about decreased activity and anomalous events across multiple components of the application service. And as you can see, there are 4 kind of alerts in there. So when I open this alert group, I can see kind of, when I look at the descriptions, those are not really like errors. Those are kind of transaction kind of log data, which tells me that there's a transaction has been done. And as you can see, there's a decrease in those transactions. So the log engine already notified that something is changing in the behavior of the application, and we can see that less transactions are coming in. And that basically resonates with the rate that we see here. So you can see that the transaction rate going down around 1146, 47. And you can see that in my instance, alerts has been generated to say, hey, you know, there's some less transactions, there's less scalability going on. And when I open one of them, then you can see how that looks like from an log analytics point of view. So we can see that the baseline has been generated from last week. This is the orange part. And the blue line is basically the current kind of transaction rate. And we can see here at around 1149 that the transaction rate is going down here. So, and that's why this alert was generated. And of course, what you see is in this group, you don't see any errors, right? But it's an indicator, or let's say a proactive kind of alert to tell you that the scalability, or let's say the transaction rate is going down of this application. So this is kind of the first indication of the issues that's going on. What we see as well in the second kind of alert group, where we have 21 alerts together, we can see, and this one is being generated 10 minutes later, is that we have much more reactive alerts, as you can see here. So when you look at the timestamp, and maybe I can open it. So when I open this alert, and we'll sort by the generation time. So if I go in here, in here, and I sort the alerts by the event generation time, then you can still see that, let me do this, that the first alerts are still kind of proactive, so predictive kind of alerts, but that the open telemetry, which is based on thresholds, is coming like almost 10 minutes later, right? So what you can see from this kind of alerting and grouping is that the machine learning detect much more faster the issue than by setting, you know, fixed thresholds. And you can see all those anomalies that are being generated are saying that something has increasing. And when we look at this alert, for instance, then you can see that some of the response time of a particular function in the application is increasing. So in this case, the anomaly is being detected on a couch, as Margot has explained. So how does it work? When I go to the surrounding logs, you can see the log line itself. Just a moment. Oh, why is it not showing? Let me take another one. This is more or less the same. Yeah. So you can see that the message in the log line says something that my slow function took like this amount of time. So what I'm doing in my parsing is basically take this message, break it down, and then define this value as in couch. So what the engine will do is basically build up this baseline around this value. And in a normal situation, this value must be much more slower let's say maybe 0 or let's say 0.5 seconds or 1 second, but now it's going sky high. So this kind of metric is also possible to to learn from a log point of view. And I will show you later how this is done. Okay, so back to the alert itself. And as you can see, we have different sources are coming together in this grouping. So that also reduced, of course, into, the kind of the noise. And this whole group has been summarized in this incident. And what you see in this incident is that I'm using the Now Assist for ITOM to summarize all those events in this single group. So what you see here is the text that being generated out of GenAI and being used as a kind of description or summary in the incident. So me as an operator, I can see right away on the situation. So I can read this and understand, what the high level situation is. So, and this is of course a benefit of using GenAI to look at across those different alerts, summarize it for you so that it's become much more readable and much more understandable. Cool. So what we can see as well is that in the alert group, we can also see possible root causes. As I mentioned in the beginning, or in the context of the situation, we have done a deployment here, as you can see here in my observability tool. So when I go to the possible root causes, is that we can look at changes that are being associated with this application service. And maybe, that particular change can be a root cause of the situation itself. So when the alerts start arriving in the system, then what we can do is using our platform data to kind of correlate this with other type of data. And in this case, we have find some changes that are being created before, let's say, the alerts are arriving. So now me as an operator, I can look into those changes and see, what kind of things has been done in these chains. And since we also support kind of automated chains from a pipeline point of view, we can basically associate all those different data that comes from the pipeline into these chains. And one of the things that I can see easily, what kind of code commits has been done for this application. So if I click on this particular commit, then I can see all the details, and then using this commit URL, then I can find that something has been enabled in the code, which definitely makes the whole application slow. So that allows me as an operator, first of all, when I go back to my express list, to be proactive by acting on those alerts that tell me that, hey, the whole application slows down, there's less activity, and we find definitely some anomalies in your logs. But 10 minutes later, I basically get the kind of the threshold kind of warnings that tells me that the latency increased. So, and with the power of the platform that we have all this data from service operation management in our platform, we can make the correlations with, changes and incidents. Okay, so how does it work? Because, what we see here, we have different alerts in the same group. So I'm using kind of the text of those alerts to group them together. So based on the enrichment that takes place on the alert level, I can now easily group those alerts together and make it a single group. Those different log lines that I'm basically where what you see here is of course coming from the analysis of our machine learning engine. And to do this, as Mar already explained, we need to map this to a kind of application service or a CI in the CMDB. And this is happening, of course, in the background. But just to show you quickly how that works, if I go to my ServiceNow instance, the first thing I need to do is to define my data input mapping. So in the data input mapping, here's the place where you associate a log line with an CI or an application service. So in this case, what you see here is when the log line arrives, so this is the example here, the parser will then allows me to do kind of JavaScripting, to kind of filter on particular values. And those values I can use to associate this log line to an CI in the CMDB. And what you see here, when I run those test outcomes, then you can see that the different log lines are being associated to different CIs. So this is kind of the first step, and of course those log lines that I receive from a Kubernetes cluster, they have of course the pod name, which basically I associate with the microservice. Now the second step, of course, is to parse and to make kind of key pairs values, and that basically happens in the source type structure. And in the source type structure, there's basically where the magic happens. And in my case, as you can see here, so this is the full kind of log line here. So by default, the parser will recognize some of the keys. And because of some keywords that we define, we associate automatically some of the labels. But of course, you can influence that. But as you can see here, I also doing some extra parsing. And what you see here is, for instance, reading the status of the request itself. And this is a kind of a meter. And here we can see the milliseconds that I'm using for the response time. So those are the things that I parse out of the log line and define it as a couch and a meter. And couch will, of course, keep track of the value in difference. And this one will basically look at the occurrence of the metric itself. What we see here as well is the automatic root cause, the RACs, and they are being used to analyze kind of the alerts that you will receive. And to show you that is, I will show you what it means, the RAC. So when I have a log alert, then of course I want to have some extra information to understand more context. And this is basically where the RAC comes into play. So when I open one of them, let me open the one that makes it very clear. Let me see this one here. So as you can see here, I have here the anomaly, and you can see definitely the reason why. But if I go to the calls, there's basically where the breakdown is of the log line itself. So this gives me much more meaningful log properties, so I can understand much more of the context of those log lines. And all these meaningful log properties, they are coming out of the log line itself, and they being defined as RAC, as I've showed you before. So if I may recap, in my situation, as you can see, I have received first the kind of the predictive alerts. And they tell me something about that there is some changes going on in the application itself, right? So there's less transactions coming in. Of course, for an operator, that can be already an indicator that, that he needs to start doing analysis. What we see as well, based on some thresholds in combination with predictive alerts, which basically happens 10 minutes later, we can see that the situation really get out of control, and we can see that the latency going up much more too high, and if we have reacted earlier, because also in this alert, in this group alert, we can see that there is a recommendation or kind of a possible root cause. So if I go to related records and I go to possible root causes, then I can see the same changes. So also here in this predictive alert, we have also the possibility to show you the possible root causes with being associated to the changes that has been done. Right, so this is my demo. Hopefully that was clear. I'm not sure if there's any questions on it.
No, there was a couple of questions, but has been answered.
Okay. Did I forgot to show something, Remco or Maro, which we maybe could be interesting to go in a little bit more details?
I think you covered it.
Yeah.
Okay. Then
all of this is geared towards reducing MTTD, mean time to detect, move to a more predictive and in that proactive state, and generally reduce not only the duration of your outages, but over time, the quantity of your outages through that more means of proactive refactoring, problem solving, triaging, investigation, etc. And I want to draw your attention in the top right corner. As I mentioned at the start of the session, this is one of many sessions to follow next year as we work on bringing the Power Hour series back. And so if you have feedback on things that you'd like to see, if you have feedback on how this session went, if you want to give us some suggestions on ways to make improvements or to spend our time in the next year, please feel free to use the QR code in the top right corner. You can also use the same form to provide feedback on the prior 2 days worth of sessions if you missed your opportunity to do that. And I believe with that, we are done with our series. I want to wish everybody a great Thursday. I hope you wrap up your week with as little stress as possible. And thank you again for joining us on this series on behalf of myself and my colleagues here at ServiceNow. Thank you.